the upside here is when a user uploads a file now, and the web server is using SUPHP, that file will be saved on the disk as owned by user A. And B's files will be saved as user B. By contrast, in the other model, where everything gets run by Apache, who saves the files? Apache, which means Apache owns the files. And that means the only way to ensure that they can be accessed subsequently is to make them world readable, which means all of the new content your users are uploading is going to be readable by customer A and B and C and D on the system. So in short, this is good. And this is not a feature that's typically advertised significantly by web hosts. I don't even know if DreamHost does it these days. I'm going to guess they don't because we didn't see mention of it, but don't hold me to that. You might want to dig a little deeper into the fine print. But if you are using something like a virtual private server, you can also avoid this issue altogether because at least if you own the whole server, even if it's a rented virtual machine, at least there's no other customers on the same server. So again, something to be mindful of so that, when you pay $8.95, $5.99, whatever it is per month, again, you're getting what you pay for. And if you care about your intellectual property and the security of your site, these are the kinds of questions you should be mindful of asking or reading up on before signing up. So SUPHP is something that will be installed in the appliance. So for those who'd like to read up on the language itself, this week there'll just be some recommended readings of sorts. Realize that there's some good tutorials online. And again, if you have a programming background in any syntactically similar language, some of this might even be boring, which would be great because it will walk you through for loops and while loops and the like. So we'll just do a quick tour of some of the syntactic details tonight, but then focus on some of the higher level concepts that will be distinct to web programming. So without further ado, one of the more stupid details, but just put it out there because it's the first thing you see. Variables, again, start with $signs in PHP. And here's the rule as to what is valid. In short, I would choose variables in a sort of normal way, typically with alphabetical letters. But there are some other things you can use like underscores and numbers and the like. But again, we won't spend too much time on this kind of level of detail. Data types. PHP is what's called a loosely typed language, which means the data types exist, kind of, but they're not readily enforced in the same way that they are in Java or in C or in C++. So what data types exist? Booleans, integers, floats, and strings. But when you declare a variable, you do not specify its type. It is inferred by the type of value you actually put inside of it. So if you say something like $x, because again, $sign means this is a variable. $x is a very boring name for a variable, but it's a variable. Equal sign, 1, 2, 3, semicolon, that data, the data type of that value will be integer, even though I didn't specify it as such. If by contrast I say $x equals 1.23, semicolon, it's instead going to be what? Yeah. Float, a floating point value, a real number. If you instead say equals true or equals false, it's going to be a bool. If you instead say quote unquote hello, it's going to be a string. But that type is not invariant. If you try to use a string in a Boolean context, you will get a lot of implicit conversion. So in other words, in an if condition, normally you would say something like if x equals y. Or you would say if true, something like that. If instead you say if quote unquote hello, well, hello will be implicitly casted to a Boolean. And because hello is not the number 0, the Boolean value of hello is going to be true. So you can use strings even as truth values, which can encourage sloppy programming. And we'll see some examples of this. But it's also useful sometimes in that it's not as pedantic a language as something like Java, where you're constantly casting things back and forth. Yeah?
Can you perform string operations on integers or vice versa?
Good question. Can you perform string operations on integers and vice versa? Yes. They will be upcasted to a string in that case and become part of the string itself. And one of the motivations for this is that PHP from the start was really designed to be web-centric. And the reality is when you're writing web software, you're interacting with the user entirely via strings. Now, the user might type in 1, 2, 3, but as we've seen via HTTP GET and talked about HTTP POST, it's all text at the end of the day. There's no data type associated with an HTML input field. So even though the user might type 1, 2, 3, what's going to be sent to the server is quote unquote 1, 2, 3. And so the fact that there is this loose typing is reasonably consistent with what you're getting from the user anyway, even though, again, it can feel a little messy, and it is, in some sense, But that's at least one of the original motivations for it. In terms of objects and collections, PHP has arrays, and it also has objects. More on those to come. It also has things called resources. Resource is something like when you open a file, what you get back is not the file per se. You get what's sort of like a pointer or a reference in C or Java speak, and that reference is to a resource, which is sort of like a special object that contains interesting information, the size of the file, your location in it, the type of it, and so forth. Details like that. Null is null. It's when you have no value there. You can have the value null as a placeholder. But variables in PHP, as we'll see, can also be set or not set. So null is an actual value. It doesn't mean the absence of a value. You can have the absence of a value, as we'll soon see. And then there's mixed. So mixed isn't really a type, but you'll see these things in documentation in particular. If you see on php.net documentation that says this function takes mixed, what does that mean? Well, it means it can take any number of different types. It can accept a string or a number. And this is where PHP is both handy but also a little sloppy, in that it's not strictly typed or strongly typed. Number means integer or float if the function doesn't care. And a callback is a function pointer. We won't spend too much time on those, but you can pass functions around by pointers or by references, generally known as a callback in this case. Another word on mixed. PHP is very common for its design of returning mixed data types. So it's very common in PHP for a function, even like date, to return strings. But if something goes wrong, it could actually return a bool. And what's it going to return in that case? False. So it's very common in PHP functions that 99% of the time it will return a certain data type, but it could return something very different. So learning to check for that correctly is good in the context of PHP. So I'll point that out along the way as well. So now some special variables before we start writing some code. So in PHP, there are special global variables that are called superglobals. They are in scope, so to speak, everywhere. In any line of code you write, so long as it's executed by a web server, you have access to these variables. They start with $signs, start with underscores, and then all caps. So $_get is a variable. It's going to be an array. It's going to be an associative array, aka hash table, aka not really an object, but it's a key value store. What do you think is in the variable called $_get? Take a guess. Yeah.
All the things that are in the URL that the form sent.
Exactly. So Q equals Harvard, foo equals bar, baz equals quux, whatever the user submitted via the form is going to be handed to you on a platter, so to speak, in the form of this variable, so that if you want the value of Q, you just have to look inside that variable. And this is one of the things that's compelling about PHP. In contrast, language like Perl, which was very popular years ago for web programming, you had to jump through hoops or use an external popular library to actually parse the HTTP requests to get access to the keys and values. PHP and frameworks like Django and Ruby on Rails make this so much easier these days. And PHP does this through these superglobals. $_post, probably guess what that does. Anything you post ends up in that array. $_files is great too. If you do let the user upload photos or whatnot, you're handed the files in the form of an array. You don't have to parse it or figure out how to deal with file uploads yourself. Super easy in that sense. Some of the more esoteric ones now are server and env. Server contains things like the user's IP address. There are user agents. What was user agent? Yeah? The browser and the operating system, that cryptic string that is apparently being sent every time the browser visits you. Env is in for environment variables, rarely used, but it gives you access to lower level details on the machine. Cookie is nice, and we'll come back to that next week, but cookie stores cookies, key values that you might send or receive from browsers. $_request has all of the interesting details about the user's request. What path did they request? Was there a question mark in the URL with parameters? It gives you access to the raw details before they end up in a more user-friendly place like get and post and cookie. And session is one of the most powerful ones, arguably. It is the thing that allows you to implement state and implement things like shopping carts. Even though HTTP, as we sort of began to discuss on Monday, is stateless, and that as soon as you visit a page and you disconnect from the server and the page is loaded, you no longer have a connection to that server anymore, via cookies, you can remember, or rather a server can remember that you're logged in. And we likened the cookie on Monday to like a hand stamp. And what is session? Session is this amazing superglobal in PHP that you, the programmer, can put anything you want in it, any keys and values, any numbers, any strings, any ISBNs of things users put in their shopping cart. And the next time the user visits your website, so long as their cookie hasn't expired, you can access that exact same data in $_session magically, so to speak. You don't have to worry about figuring out who the user is. PHP and in turn the web server do all of that for you out of the box. So again, another upside of a language like this. So let's actually see this in action rather than talking about it in the abstract. So last time, recall that we had this file. Let me go to cs75.net, lectures, where we posted the video and more. And in our source code directory, typically if we write some source code on the fly during lecture, I'll clean it up and then upload it the next day to the server if you want to play around so you don't have to write down code and whatnot. Or if we have some stuff in advance, I'll put it there. So this is from Monday. And we had this site, Google and Google Search. And when I submitted this, recall that if I searched for Harvard, enter, I ended up at... Oh, we broke it. I should fix it. I will fix this. Recall that I broke it at the very end of class by changing the value of Q to something else altogether. I think I said like QQQ or something random like that. So let's now, instead of using Google to do our backend, let's instead write the backend ourselves. So I'm going to go ahead and do this. First, let me grab this page source, and I'm going to open up our little text editor as before. And yeah, this is what I did wrong last time. So now it's back to Q. But this time, I'm going to change this to point at my own server. So then a word on the server. If I scroll over here, this is my CS50 appliance, the virtual machine that in a week and a half's time we'll start using as well. And it's a Linux computer. But more than that, even though it looks like a desktop with a little start-like menu in Windows, it's still a server. And I can see this as follows. If I go ahead and inside of the appliance, I visit Google, I see Google. But if instead I do http://localhost, localhost is the common name for a Linux computer when you're on the Linux computer itself. And this is true in Mac OS as well and sort of in Windows. Localhost refers to the computer you're on. So when I visit http://localhost, and let's just say /enter, I should see the root directory of the web server. So this is what I'm seeing. The fact that I'm seeing this page, and actually it tells us literally what it is. This page is used to test the proper operation of the Apache HTTP server after it's been installed. If you can read this page, it means the web server is installed at the site working properly but has not yet been configured. So that's great. That's exactly what I wanted to see. Some mentioned that web server's working, and now it's up to me to actually populate it with some data. Now I can do something else now. And these kinds of steps, if you're unfamiliar, we will explain in the first, before the first project. What I've done is, right now, is I've opened up a so-called terminal window. This is an old-school black and white interface for navigating the contents of a computer. It's like the DOS prompt of yesteryear. Mac OS, it's the terminal window. Windows sort of has an analog in the command prompt, but it's not as flexible as on Linux and Mac OS. And I can do a few things here. Again, we'll document this more in the future, but this is the fairly arcane command for making a directory. mkdir space the name of the directory. And I'm going to go ahead and hit enter. And what that will do for me, ignore the control C, is I can now do cd public HTML, and that stands for change directory. And in change directory, now I am inside of this. So cd is like double-clicking a folder in a modern operating system, which then opens a new window. So cd has now put me inside of public HTML. So now I'm going to go ahead and do this. I'm going to go ahead and run a command like gedit hello, or let's do google.html. Gedit happens to be a text editor for Linux, so it's like TextEdit, it's like notepad.exe, but this one's a little nicer in that it supports something called syntax highlighting, whereby my code will be colorized to be more user-friendly. So let me go ahead and copy what we wrote on Monday over here and paste it in. So this is what I mean by syntax highlighted. It's just pink and purple and whatnot, just to draw our attention to semantically the different parts of the web page. And now I'm going to go ahead and hit save. So Control S, or I can go to the File menu. And now let me go back to that terminal window. And again, I'm back in Linux here. And I'm going to go ahead and do ls. And notice I have a file called google.html. And I can do all sorts of commands. There's the cat command, which shows you the contents of files. There's the more command, which shows you the contents of files. I can do any number of things. I can accidentally delete it with the rm command. Don't do that. But I can do all sorts of things at the so-called command line that I could do with a mouse and a keyboard traditionally. So what's the takeaway here? Now that I have google.html, notice that I have it in my public HTML directory. But if you can infer, who am I at the moment? What's my username? Yeah. J. Harvard. So I am John Harvard. Why is that? Well, we configure this particular virtual machine with a generic username, John Harvard, so that anyone can use it, and so that in documentation and whatnot, we can tell you exactly what your username is. It just gets a little more annoying if everyone has unique addresses, because troubleshooting's harder and so forth. So just assume you've signed up for a web hosting company. They have arbitrarily told you your username will be J. Harvard instead of A or B. So now I'm in John Harvard's so-called home directory, the folder that I get for all my storage. And in there, I created the public HTML subdirectory, or folder. And in there, just to be clear, what's inside of public HTML at this point in the story? Google.html. So how do I visit Google.html? Well, I'm going to go open my Chrome browser. And rather than visit just localhost, I'm going to actually do this. http://localhost/tilde jharvard/google.html. So this is a convention on a lot of web servers. When you want to access a specific person's home directory, you do /tilde username /file name. You do not type what, apparently? Public HTML. So public HTML is implied by the fact that you're using the URL. So don't type public HTML in the URL itself. And now I'm going to go ahead and hit enter. And voila, damn it, broken. So what does this mean? First of all, what's the status code here? Does anyone spot it? Yeah. Forbidden. 403. You can see it in the tab at the very top. So that's one of those more arcane status codes. 404 is a little more common. File not found. File's there, but I'm forbidden. So just high level in English, what does this mean? Yeah. I haven't set the permissions. So we talked earlier about the idea of global permissions. Now let's frame this in a Linux context. And again, Mac OS is very similar. Windows isn't quite the same process, but the ideas exist on all of these platforms. So let me do ls for list again. This is like dir if you come from a Windows world. And I see google.html. Not all that enlightening. But I can do a long listing. So ls-l and then hit enter. So -L, for those less familiar with Linux or unfamiliar, is a switch, a command line switch or flag or option, whatever you want to call it, that modifies the behavior of the command, which in this case is called ls, enter. And now I see more output. What do I see now? I see first who owns the file, what is their group, and by default the appliance is configured so that there's a students group, and there's only one student for everyone called J. Harvard. But when you install your appliance, you're not sharing the same appliance. You all have your own copy of the appliance with one J. Harvard account. This means it is 424 bytes, which means 424 characters I typed into that file. This is when we last edited it. This is the name of the file. And I skipped the most interesting part, which is over here. Now, this is maybe a little cryptic, but RW generally denotes read and write. And what we have here is an indication of 3 types of permissions. So this is a very quick crash course. Again, you don't need to commit all of this to memory yet, because this will come up again in the actual projects. But what we've just done here is, let me actually copy and paste this. We have this sequence here. What in the world does this mean? Well, first I'm going to cheat, and I'm going to get rid of this one. The first dash is either a D if it's a directory, or a hyphen if it's a file, or something else if it's something else. But for now, let's just assume that directories and files are all that exist. So now there's this, and let me put some spaces in. It looks like we have a pattern of triples here. The first triple is the owner, so to speak. The second sequence is the group, in this case students, and then the last is the world. So what is the implication right now? The owner can read and write this file. The group, students, can read and write. That feels a little worrisome, but in this case, the virtual machine is on my own computer. There's a students group, but I'm the only student, so this is kind of immaterial. So it's not great, but not bad. It's not applicable at the moment. The whole world, though, can read this, and that's what I want for an HTML file. So it feels like my permissions are right. What else could be wrong then? Again, context is web server's running as Apache, or some username that's not me right now. But we have to give him access to it. Yeah?
Pass.
OK.
But could it have to do with the last hash?
The last dash. In this case, no. This is actually OK, and others would be possible. Technically, RW R would be fine, or even RW nothing R would be fine. Point is that the world has to be able to read it. But what else does the world have to be able to have access to, do you think? The directory, right? We got to go one level higher. So how can I do this? Well, when I did ls-l a moment ago, I only saw the file. Let me do ls-al, which is all and long, or I can do this. You can combine switches typically in Linux, just for convenience, like this. AL, now I see more. The first two lines are dot and dot dot. What does dot represent in a typical file system? Sure. Close. What does dot represent? Let me change the question. What does dot dot represent? Excellent. It means the directory above, so dot dot. So dot, though, by contrast, represents the current folder, the one that you're in. So dot is where you are. Dot dot is your so-called parent, which means the thing you're inside of, what the parent folder is, that your folder is inside of. So dot here refers to a directory called public HTML. Dot dot refers to my home directory. And now, I know what it is. Damn it. OK, so I'm going to have to fake this story slightly for just a moment. Everything is actually correct. There is another secret setting that I changed earlier in the week while playing with the virtual machine that explains this. It's a feature called SE Linux for Security Enhanced Linux, which disallows anyone, including John Harvard, from using the web. So let me see if I can quickly fix this. But this was a wonderful stroll down the diagnostic techniques that would have led us to the solution. Whoops. And we go here. OK. So, OK. So this is a detail you will not trip over yourself, because by default, what I just did is already done for you. It's just I disabled it while playing around the other day. This was an additional security mechanism called SE Linux, which comes with flavors of Linux like Fedora and CentOS and Red Hat, and is meant to lock down systems even more. But doesn't matter, because the story we told is still very much the same. In fact, I can simulate now how we could have created a problem for ourselves as follows. Let me go into this directory, and everything now looks correct. All of this is good because it means a few things. Google.html is readable by the world. What do you think X means for both dot and dot dot? Executable. Now, normally executable means like execute a file, run a program. But that's not the case for directories, because notice the D and the D. For directories, if a directory is executable, that means someone can get into it. They can't necessarily read it and see the contents. R is read. Execute means they can do the equivalent of CD into it. Or they can visit a URL that contains that directory's name. So the fact that this is X, and this is R is actually perfect. That's what we want. But I can simulate it being wrong. Suppose that by default, when I'd created this file, it looked like this. What's wrong now with this picture? What jumps out at you? Yeah. Perfect. Only read writable by the owner. No one else can read it. That's a problem. So there's a bunch of ways to fix this, but the way we'll introduce for now is chmod, which is change mode, and then A for all, aka everybody, plus, what do I want to give everyone? R. So a little arcane, the syntax, but then this command gives it what we want. Change the mode of the Google.html to give everyone R. The plus means give, minus means subtract. So enter, ls-al, and now that problem is solved. By contrast, if the directories looked like this, propose to me how we fix this problem now. Now my dot and dot dot directories are no longer executable, which means my file is readable, but no one can get into this directory via the web. How do I fix this? OK, good. A plus X for executability, and then the name of the file, which is or folder, which is dot, and I can actually put a space-separated list of these things on the command line. I can hit that, and now ls-al, we fix that problem too. Now suppose I goof, and suppose I do chmod a plus x google.html. You can maybe guess what's going to change. So think to yourself, what is this line going to look like in just a second Now it has an X everywhere as well. Does this mean anything? In this case, no. It's an HTML file. It's a static file. Making it executable means nothing. And so is this going to break anything? No. It's just kind of wrong in principle. However, sometimes with PHP, your PHP files need to be executable. That is not the case on most web servers.